Hi, another application with gases and gas laws. We're going to talk about mole fraction combined with gases. So here is our formula for mole fraction. We use X, and then the subscript is for your gas, your element, or it could be a compound as well. So mole fraction of a substance is going to be the moles of that substance divided by the total moles in that mixture. Now, really important, leave this as a decimal. It's going to be different from like percent mass or percent volume where you multiply by 100. This one you leave it as a decimal, don't multiply by 100. So I have an example here. We're going to have a mixture of some oxygen and some nitrogen. So we have 0.6 moles of oxygen and 0.8 moles of nitrogen. And I want to know the mole fraction of both of these. So to find the mole fraction of oxygen, I simply take the moles of oxygen and I divide it by the total moles. Well, the total moles, N sub T, is simply going to be moles of oxygen plus moles of nitrogen. Total moles will be 0.6 plus 0.8, which is 1.4 moles. So there are my total moles inside this mixture. So divide this by the 1.4, and we are going to get 0.43, and that's going to be for the oxygen. So let's now do the mole fraction of nitrogen. Now, there is a shortcut to this. You're thinking mole fraction of the total. Without doing this math, can you think of another way to find the mole fraction of nitrogen? I'll set this up while you think about it. Another way to find the mole fraction. So here's moles of nitrogen, 0.8, divided by total moles, 1.4, gives me 0.57. You might be able to see it if you didn't just think it. When you add the mole fractions together, they always have to equal 1. They have to equal 1.
Pardon this interruption. We'd like to just
Good work, you guys.